Episode number 2, variables and simple data types. Let's get started. Last time we wrote our first Python program, we made a variable called test and assigned a value to it, and then we printed that value, like you can see here. Let's just talk about what actually happens when you run a Python program. There is something called the Python interpreter, and this is a software component that is responsible for reading, interpreting, and executing your code. So essentially, it turns human readable code into machine readable instructions. So the Python interpreter will read through each line of code and determine what each word means. When it sees the word print followed by parentheses, it knows that this is something that should be printed to the console. Now that we know what a Python interpreter is, let's move on to variables. And we made one last time called test. Variables are often thought of as boxes in which you can store values in, but it's actually more accurate to think about variables as labels that you assign values to. This distinction may not matter too much in the beginning, but it is important once we get more advanced. When making a variable, you can give it almost any name. We used test last time. I could also write elephant is equal to 1. I could write monkey is equal to 2, and so on and so on. You can give it almost any name, but there are a couple of rules that we need to adhere to when making variable names. Variables can contain numbers and underscores, so I can write monkey underscore 3 equals to 3, for instance. But it cannot start with a number, so I can't write 3 underscore monkey is equal to 3. This won't work. Another thing we can't do when naming variables is using spaces. So if I write 3 elephants is equal to 3, this also gives me an error. But if I want to have a name like this, 3 elephants, I could use an underscore, and this will be totally fine. So if I run this, you can see that I have gotten my 3 elephants variable up here. We also want to avoid using Python functions as our variable names. These functions are reserved for a particular programmatic purpose, for instance, print up here. But what we can do instead, if I wanted to have a variable that has print included, we can write print underscore elephant, for instance, equals to something, and that will be fine. Up until now, you have only seen me assigning these variable labels to numbers. And this brings me to the next part of the video where I will cover 3 simple data types in Python. Those are strings, integers, and floats. Simply put, a string is a sequence of characters. If we go ahead and delete all of this, we can create a string and assign a variable label to it. So let's make a variable, call it string, and let's make a string starting with quotation marks. So you can use single quotation marks or double or triple, doesn't really matter. Let's write this is a string and run the program. Now over in our variable explorer, we can see the variable name string and type string, size 16. This is the number of characters, and our value is the sequence of characters that we typed within the quotation marks. I can also make it with double quotation marks. So string 2 is equal to, this is also a string. You can see I use double quotation marks. Let's run that. And we can also see it over in the variable explorer. We can also use quotation marks within our string. So let me show you what that looks like. Let's make a variable called Alex set equal to single quotation marks. Alex set bring me my coffee. And you can see I use double quotation marks in here. And if I run this, we do see the double quotation marks in the sequence of characters. I can also try and print this, print Alex set. And do note I used a capital A in this variable name, so I also have to be aware of that when I print it down here, or else it won't work. So if I print, we can see in the console, Alex set, bring me my coffee. We can also concatenate strings, and concatenation refers to the act of linking or combining things together. I'll just delete this, and we make a new variable. Let's call it coffee. I can make a string that says Alex wants, and then I can make a plus sign, new string, a cup of coffee. So essentially I'm taking 2 strings and combining them together. Let's see what happens when I run this. The coffee variable is now visible in the variable explorer, and we can see the sequence of characters. Alex wants a cup of coffee. So there is no space between our two strings. The way we can fix that is say plus, and then an empty string, and then another plus. So now we're saying this string plus an empty string, which also should have a space, plus a cup of coffee. So if we run it now, we can see the sequence of characters makes sense. Let's just print it to make sure. So we say print coffee and run it. Alex wants a cup of coffee. Another thing I think is very important to get familiar with is the use of f strings. And it essentially allows you to take the values of variables and put them inside strings. So let me show you what that looks like. So let's delete this print statement. Now we can take these two strings and store them in different variables. So let's say wants is equals to Alex wants. And then we will make one called coffee. We already have one up here that's called coffee. So let's just call it coffee2. In here, we will say a cup of coffee. Now I can use an f string in my next variable. So let's call it wants coffee. It's equals to f and then quotation marks. So now the program knows that this is an f string. So I am allowed to use curly brackets to put in my variables. So you can see the wants variable up here is inside the curly brackets. And then I can use a regular space, another curly bracket, and write my coffee variable. And if I print wants coffee, we should get the same as we got before. So print wants coffee, and let's run it. Alex wants a cup of coffee, and it is the same as the last one. So different ways to achieve the same goal. But what happens if I don't have a string as my variable inside my f string? So let's say wants is instead of equal to a string, it is equal to a number, so 1. And if we print this, it will just say 1, a cup of coffee. The point is that the f string allows me to put in variables that have values that are not strings. This is not a string, this is a number, but still it is included inside my f string. You can also manipulate what it looks like when you print a string, so the output. We can go ahead and delete this. So if I say print, and then I make a string where it just says coffee, I can also add a backslash and a T. And if I run this, I have added some white space to this output. So this tab length of white space. If I instead add backslash N and run this, we can see that it actually prints it on the next line. So this is just a few tricks to alter the output when printing strings. And of course, I could also add these to the strings I've made up here and just change this first one so that it makes sense. Again, Alex wants. So what does it look like when we print it? Wants coffee. Alex wants a cup of coffee, and we can see it's on the next line. The next simple data type is integers. Let's clean our space here and also remove all our variables so we are ready. Integers are a numeric data type used to represent whole numbers in Python. We saw this in the first program that we wrote, which was test is equal to 1, a whole number, an integer, and then we printed test to C1. And we also inspected it in the variable explorer, and we saw the data type was integer. But let's see what we can do with integers. We can test some basic mathematical operations and see how they work. We'll delete that and add a print statement. So I will pick an integer, let's say 2, and then I can add a plus sign and another integer. And if we run this, we can see in the console, we get 6. I could also make this into a subtraction. So 6 minus 4, for instance, and we get 2. And let's try using an asterisk to multiply, and we get 24. And the same thing with a forward slash. If we divide this, we get 1.5. That is pretty straightforward. Exponents are represented by a double asterisk. So I could say 6 to the power of 2, for instance. That's 36. Python also supports multiple operations within one expression. We can write 6, for instance, plus 2 times 2, and we will get 10. We can also change the order of operations by using parentheses. So like that. and print this, and we'll get 16 instead. As soon as a number in Python contains decimals, it goes from being an integer to a float. Let's go ahead and see what that looks like. So test equals to 0.1. And we can see in the variable explorer that it is indeed of type float. Now we can use the same mathematical operations as we did with the integers. So let's go ahead and delete this. Print 0.1 plus 0.1, and we can run it. We get 0.2. Let's try and multiply. And here you can see we're getting an awful lot of decimal places. This is not to worry about, it's just Python trying to be as accurate as it possibly can. But if we don't want to look at that, we can use the round function. You just type round with double parentheses. And if we run this, we're getting 0. I can also specify the number of decimal places that I want. And I do that by making a comma and then let's say 2. And now we should get 0.01. The last thing I want to cover with Python numbers is multiple assignment. This allows us to write one line of code that assigns multiple label variables to multiple values. Let's see how that works. I can delete this, and then I can write x, comma y, comma c. I am making 3 separate variables. They're separated by a comma, equal to 1, 2, 3. And if I run this, they appear in my variable explorer up here. We can also see that x is equal to 1, y is equal to 2, and c is equal to 3. And let's just print it just to make sure. And we get 1, 2, 3 in the console. That's it for this episode. I hope you enjoyed, and I hope to see you in the next one where I will go through Python lists.